So we've been talking about factoring for the past couple of days, and we are going to learn about a special case of factoring called a difference of perfect squares. Before we get into what that means, let's review our squares. So like 1 squared would mean 1 times 1, which is 1. 2 squared would be 2 times 2, which is 4. 3 squared is 3 times 3, and that's 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81, and 10 squared is 100. And these are going to come in very handy later. So when we're talking about the difference of perfect squares, difference in math means that we are subtracting. And perfect squares, we would say, is something that can be written as a number or something times itself. Something that is multiplied by itself. So all of these up here, 1, 4, 9, 16, 25, 181, 64, 49, and 36 are perfect squares because they can all be written as some number times itself. For example, 81 would be 9 squared. So 81 is a perfect square. So when we have a polynomial that's a binomial really, that's a difference of perfect squares, that means that there's a subtraction sign in the middle as we see here, and two things that are representative of something multiplied by itself. So a squared would be a times a, and b squared is b times b. And whenever you have a squared minus b squared, so something that looks like this, it's going to factor really nicely into a minus b times a plus b. And every time this will be true. So we're going to look at some examples down here. So number 1 says s squared minus 49. Well, s squared is s times s. 49 is 7 times 7. So this is a difference, a subtraction of two perfect squares, so s times s and 7 times 7. So this factors really nicely into s minus 7 and s plus 7. So notice my parentheses are identical. They both have s and 7. And those s's came from here. That's where the s's came from. And then my 7 came from these two numbers, my 7 times 7. So this factors really well into s minus 7 times s plus 7. So if I have t squared minus 81, well, t squared is t times t. 81 is 9 times 9. So this will factor into t minus 9 times t plus 9. And it does not matter if the plus is first or the minus is first. That information is not important. But what matters is that you have one of each. So number 3 is still a problem like this. It says 16 minus x squared. Well, 16 is 4 times 4, and x squared is x times x. So this will factor into 4 minus x times 4 plus x. I want you to notice that this time my number came first, the 4 was first, and the reason the 4 was first was because the 4 times 4 gave us our 16, and that was what came first in our problem. So for the second half of it, which was our x and our x, that's why x went second in the parentheses. So problem 4 is, again, while it doesn't necessarily appear to be, a difference of squares. And the reason this is a difference of perfect squares is because 4g squared is really 2g times 2g. Because 4 is 2 times 2, and g squared is g times g. And then the 25 is 5 times 5. So just like all the others, this will factor nicely into 2g plus 5 and 2g minus 5. So notice that my 2g's went first in my parentheses because that was the first part of my problem, and then my 5 went second because that was the second part of the problem. For 5 and 6, I'd like for you to pause the video and then try to work 5 and 6 out on your own to see if you can figure those two out, and then unpause the video to see if you got the solutions correct. So for problem 6, 36h squared was 6h times 6h. So notice I put a 6h in the first half of each parentheses. 121, that was a little hard to figure out, was 11 times 11. So that's where my two 11s came from. And notice one parentheses has a plus and one has a minus. So my answer was 6h plus 11 and 6h minus 11. Problem 6. 81 minus 49k squared became 9 plus 7k times 9 minus 7k, because 9 times 9 gave us our 81, so that's where these 9s came from. And the 7k's came because 7k times 7k is 49k squared. When I'm factoring, just the steps to remember, like for Algebra 1, just the basic factoring that we're going to do. First and foremost, always look for a GCF. Always look to see if you can divide all the terms in a problem by something. Number 2, figure out, is it a difference of perfect squares? That's what we just learned about. The difference of perfect squares problems are going to be in the form of a squared minus b squared. So it's something squared minus something else squared, and that will factor really nicely for us. And if that doesn't work, then we can use the AC method, which we've been using all along. So there is a second type of of special case for trinomials, and this is called a perfect square trinomial. These are a little harder to identify. They're written in the form of something squared plus 2 times whatever was squared times whatever squared here plus that part squared. This is going to make a little bit more sense when we start looking at numbers. But both of these, when they're written like this, they factor really well. So if you can find something that's written like a squared plus 2ab plus b squared, then it's going to factor into a plus b squared. And if it's a squared minus 2ab plus b squared, it's going to factor into a minus b. So we're going to look at a couple easy examples to help us figure this out. We're going to start with 7. I'm going to tell you that 7 is a perfect square trinomial. So if it's a perfect square trinomial, then it's written in the form of a squared plus 2ab plus b squared. So let's look at each of the pieces. Well, x squared, that would mean that this would be x times x. That's where so a in this case would be x. B, 16 is 4 times 4, so B is 4. And this middle part here, this 8x, well, 8x is the same thing as 2 times A, which is x, times 4, and 2 times 4 is 8x. Again, these are harder to see, and I acknowledge that. But if you can figure them out, it makes your life a lot easier. So since this is a perfect square trinomial and A was x and B was 4, well, this is going to factor into x plus 4 squared. And that's my answer. Now, if that made absolutely no sense to you and you're like, I have no idea what Miss Krim is talking about, you know what you can always do? You can make your chart. And you can label your left side as your product, which would be a times c, which would be 16, and the right side as your sum, which is b, and that would be 8. And 4 times 4 is going to be your set of numbers that works, because 4 times 4 is 16, and 4 plus 4 is 8. And you can go through and you can factor this the way we've been factoring. There's nothing wrong with that. So 8 is also a perfect square trinomial, because the middle piece is 2 times 5 times x. And notice 25 is 5 times 5, and x squared is x times x. So because the middle part had an x and a 5, and that 2, which is part of the formula, then it's a perfect square trinomial. So this one is going to factor into x minus 5 squared. So whatever sign shows up in front of b, this sign is always the sign that's in our problem. Just like on problem 7, it was plus 8 here in the middle, so that meant there was a plus sign in the middle of our problem. Number 9, it's a little bit harder to see this one. So let's figure out how to write this as all the square pieces, all the pieces of it. Well, 4x squared is 2x times 2x. 9 is 3 times 3. And 12x squared is 2 times 2x times 3. Because if you multiplied 2 times 2 times 3, you know what you get? 12. So the way this one is going to factor is 2x plus 3 squared. And remember that 3 comes, or that plus sign, I'm sorry, comes because that was the sign in the middle of the problem. So looking at problem 10, if you're still a little unsure about this, well, let's write the formula out. So the first thing we learned was that our formula for a perfect square trinomial was a squared, and in this case minus 2ab plus b squared. Well, a squared is a times a, so something multiplied by itself, minus 2 times a times b, plus b squared, which is b times b. So notice this middle part here is an a and a b, so an a and a b, and there's always a 2 there. And that 2 is just always there because that's how the formula works. So let's see if 16x squared minus 40x plus 25 can be written like that. Well, 16x squared, that'd be 4x times 4x. Well, that works because a times a should be something multiplied by itself, and 4x times 4x gives me 16x squared. 25 is 5 times 5. So that works because this last part should be something multiplied by itself. B times b would be 5 times 5, which is 25. So this middle piece should be minus 2, because that's the formula, times a, which would be 4x, times b, which would be 5. And I did not make this up. This 4x comes from here, and this 5 comes from the right side of my problem. Well, if we do the math, 2 times 4 is 8, and 8 times 5, guess what that is? It's 40. So this is a perfect square trinomial. So it's going to factor into 4x minus 5 squared. Again, you can always, if you want to, use the AC method. So, and this minus sign, as a reminder, gave us this minus sign in the problem. So 11, let's just keep going. If it's a perfect square trinomial, then it should be written as a times a minus 2ab plus b times b. And that comes from the formula a squared minus 2ab plus b squared that we wrote at the top of our paper. So 25 squared is 25x squared is 5x times 5x, so that works. 4 is 2 times 2. So this last part works out well. So we need to figure out if minus 20 can be written as negative 2 times a, which is 5x, times b, which is 2. Well, 2 times 5 is 10, and 10 times 2 is 20, so this works, which is really nice because now our problem factors into 5x minus 2 squared. And that comes from the 5x here, the 2, and the minus sign. That's where the 5x minus 2 comes from. Our last problem is problem 8. Well, this one has a plus sign in the middle, so this should be written as a squared plus 2ab plus b squared, which is a times a plus 2 times a times b plus b times b. Well, x squared would be x times x, b squared would be not 4 times 4. 64 is 8 times 8, so this middle part should be 2 times x times 8. Well, 2 times 8 is 16, so this is a perfect square trinomial. So it is going to factor into x plus 8 squared. Just a reminder where all these things came from. This x gave us this x and gave us this x because that was the value of a, and my 8 was the value of b, so that's where this 8 and this 8 came from. And lastly, there was a plus sign here in front of the b term, in front of the 16x part, and that's where this plus sign came from.